This video will cover how to determine conjugate acids and bases in an acid-base reaction. In any acid-base reaction, there are two conjugate acid-base pairs. Each pair is related by the loss and gain of hydrogen ions. One pair will occur in the forward direction and one pair will occur in the reverse direction. The following slides will show you how to determine which element is the conjugate acid and which element is the conjugate base. In this reaction, NH3 plus H2O yields NH4 plus OH. We have this as a reversible reaction. If the reaction proceeds in this direction, then we have H2O as our conjugate acid and OH as our conjugate base. Our conjugate acid will always have one hydrogen more than our conjugate base. If the reaction is going in the reverse form, then this will be our conjugate acid. Here we will have our conjugate base, as our acid gives up a hydrogen and it becomes the conjugate base. Here we have the reaction HF plus H2O yields F plus H3O. One conjugate acid-base pair will be the HF and the F. The HF is the conjugate acid, it donates a hydrogen, and it becomes the F. The other acid-base pair would be if the reaction proceeds in the opposite direction. Here we have H3O as our conjugate acid, it donates a hydrogen, and it becomes H2O. Each of these pairs is related by the loss and gain of hydrogen ions. In this acid-base reaction, an acid, HF, will donate a hydrogen to form its conjugate base, F. So we have our conjugate acid, it donates a hydrogen, and it becomes the conjugate base. A base, H2O, accepts a hydrogen to form a conjugate acid, H3O. So we have two conjugate acid-base pairs. Here we have some example problems in order to identify the conjugate acid and base. Example A asks us to write the conjugate base for the following conjugate acids. Now, our conjugate base will have one less hydrogen than our conjugate acid. Therefore, we have Br as our conjugate base. Also, because we are losing a hydrogen, which has a +1 charge, our charge of our chemical will drop by 1. So HBr has a 0 charge, our conjugate base would have a -1 charge. So on example 1, our conjugate base would be Br -1. In example 2, we have H2S. Our conjugate base would be HS -1. In example 3, we have H2CO3. Our conjugate base would be CO3 -1. On example B, we are asked to write the conjugate acid of the following. Therefore, we will be adding a hydrogen to each of these. So we will have HNO2. Because we're adding a positive charge, this charge drops. Here we will have NH4 with a +1 charge because we are adding a 1 charge to our 0 charge. Here we will have HOH. We added that positive charge, it dropped. You can also write this as H2O. Here you can see the examples from the previous slide and the correct answers written out. On this example, we are asked to identify the sets that contain acid-base conjugate pairs and then to identify what the acid and base would be. Number 1 has an acid-base conjugate pair. The only difference between these two examples is the number of hydrogens. Our acid has one more hydrogen than our base. Remember that our acid has a 0 charge. When we lose a hydrogen, it would drop to a -1. On example 2, this is not an acid-base conjugate pair. Notice that the charge of H2CO3 is 0. It should lose one hydrogen to become HCO3 with a -1 charge in order to be the conjugate base. Therefore, this is not a correct conjugate base. On number 3, this is not an acid-base conjugate pair. The only difference should be the absence of one hydrogen on the base. Notice that we have a CO4 here, and CO4 was not on the first. This one right here is a conjugate acid-base pair. Our acid is the H2S, and our base is the HS -1. Number 5 is also an acid-base conjugate pair. This is our acid. It has one more hydrogen than our base. Here you have the example answers from the previous slide so that you can review over these. Here we have some final example problems. The conjugate base for HCO3 -1 should be CO3 -2. Notice it lost the hydrogen and it became one additional negative level. The conjugate acid for HCO3 -1 charge would be the H2CO3. Notice that our acid has one more hydrogen than our base, and notice that we added a plus charge, so we went from a -1 to a 0 charge. The conjugate base for H2O is OH negative. It loses a hydrogen. The conjugate acid for H2O would be H3O with a positive charge. Notice it gained a hydrogen. If we are ever asked to write out a conjugate acid-base reaction, we will put our conjugate acid, and let's put H2CO3, and that will yield our conjugate base of HCO3 negative charge plus our hydrogen with a plus charge. This can be reversible. If we were to continue looking at writing out chemical reactions for conjugate acid-base pairs, if we had H3O with a +1 charge as our acid, that would yield our conjugate base of H2O. Notice that we lost the hydrogen plus our hydrogen. If we had H2SO4 as our conjugate acid, that would yield HSO4 with a -1 charge plus our hydrogen. So here we have our base, and over here we have our acids.